Hi guys, good morning. In this video, we are going to see kth largest sum in a binary tree. It was a pretty simple question if you have already seen binary trees. So let's quickly jump on to the problem statement, what it says. So it says that we are given the root of a binary tree. Firstly, it's a tree and it's a binary tree. So it means that a node, it can have two child, at max two childs, and a positive integer k. Cool. The level sum, the term level sum is defined as the sum of the values of the nodes are on the same level. Now we need to return the kth largest level sum in the tree, not necessarily distinct. Okay, if there are fewer than k levels, then we return -1. Okay, so if the levels are not even k, so we need to return -1. But if there are k or more than k levels, then we need to return the kth largest level. I hope that you guys understood the question. Let's quickly jump on to example to understand, okay, what actually says. So basically, if we have the number 5, so basically it's level 1, it's level 2, it's level 3, it's level 4, right? So these are all the levels. So the sum of this level is 5. The sum of this level is 8 plus 9, which is 17. The sum of this level is 2 plus 1 plus 3 plus 7, which is 13. The sum of this level is 4 plus 6, which is 10. Now, if we put this sum of every level in the array and we sort this array in the non-increasing order, which means in the decreasing order. So if we choose, let's say if it says, okay, we want k equal to 2, which means the second largest element, which is the kth largest level sum. So second largest element in this particular array, which we have made out of this level sum, it will be nothing but, if we sort it, let's say we get a 5, 13, a 10, sorry, we get a 5, 10, 13 and a 17. So the smallest, now it's in ascending order, so we will sort it in maybe ascending order. So from the last, the second element, it will be the second largest element, which means the second largest level sum. I hope that you guys got it. In this example itself, it's 1, 2 and 3. So the level sum would be 1, 2 and 3 because only one nodes are at each level. And it says that, okay, what's the largest? First largest sum, level sum. First largest level sum, it's itself a 3. So I'll just return a 3. It's a pretty simple. It's just how you do the implementation of this question. I hope that you guys know that how the BFS works. So a BFS is just a breadth first search. It just do one thing, that at the node, it try to iterate on the next level, which means that if I am the parent, I will try to iterate on my child's. Not yet. And then it's the same. If I am on this, so it will try to iterate on this child's, and if I am on this child's, on this parent, it try to iterate on this child's. It's just that if I am on the level 1, the BFS will try to iterate on the next level. So it's the reason we are gonna use BFS, because it iterates level wise. But it's a catch here. What's a catch? That at every level when it is computed, we need to get the sum of that level to get, because ultimately what we saw was that we will make this particular array called as or a vector, and then we will try to store our level sum, which means the sum of each level, in this vector, and ultimately maybe we can sort it and return the kth largest element. Which means that what we will do is that at every level I need to store, okay, what's the level sum like? So my BFS queue, what it does is that it just stores the particular element and all the elements in its level. When this element is removed from the queue, what we do is we just insert the child in the same queue itself. What we do in BFS is we just remove the root node and we insert its child, which is 8 and 9, in the same queue, so that we are just iterating on every element of this array. But it's not a good idea, right? Because ultimately we would need the elements only at the other level. So what we can do is we can just iterate on this queue. Okay, cool. But whatsoever are the child, and we know that the child are always at the level next level. So we will push all the child in the another queue. Let's say name it as Q2. So the blue queue, it is Q2. So I just iterate on this Q1, which is the root, and I push in all the childs in the Q2. And then what I will do is I will just, after it's done, after this whole Q1 is iterated, I'll just make my Q1 again as, okay, it's the new Q1. What I will do meanwhile is I'll just get this sum out of it. I'll just get this sum out of it. Let's see more how it actually is happening. So now our Q1 is something as 8 and 9. Now 8 and 9 is this particular row, right? Now I want the child. What are the childs of 8? It is 2 and 1. So basically I just iterated on, okay, it's Q1, okay, it's 8, okay, so it's child are 2, okay, and 1, okay, I just putting in Q2. Now it's 9, okay, 9 child is 3 and 7, okay, now it's iterated. My Q1 is iterated now. I'll get the sum of this Q1, okay, what's the sum like? Because it's the sum of level 2. And now my Q2 is ready, my Q1 is finished, I've finished iterating it, I've got the sum also of level, this particular level. Now I can just put my Q1 again as, okay, what's the new Q like? It's the Q like the what we have made in Q2. I can just replace my Q1 by Q2, and same I can go on, like I just put again the childs of the particular row right here. So it's the childs are 4 and 6. I just put it in Q2. Again I just iterated, okay, what all, I just go on until my Q1 is finished, and I am putting in Q2. As my Q1 is finished, I'll get the sum out of it, and I'll just replace my Q1 again back with Q2. So basically we are using Q1 for, let's say, root, and Q2 for the childs. Then again it's a root, it's child, root, child, like this. I hope that you guys got this. Now let's quickly see the code. It's pretty simple. As I showed earlier also, we had a vector level sum. It is to get the Q1 out of our answers. It is the Q1, which is the main Q. In this, I just had a Q2. What it will do is Q2 will store all the childs, and again I am pushing my Q as a Q2, and meanwhile I am also computing the sum of my main Q, which is this particular sum, as you can easily see, and I'm just putting all these childs of this main Q in what? In Q2. I'm putting it in Q2. It's as simple as that. And here after that we have got all the elements, which means all the level sum in my vector called as level sum. I just sorted it in the descending order, and I just got the k minus 1th indexed value, because it will be the kth largest value. And also there's a condition said that if the levels are not itself k, so I just written a -1, and it's the case. So I hope that you guys got the intuition. Okay, why is that we use BFS? Why we use BFS in general when we want to traverse level wise? We use a BFS, and in BFS we use one Q. But here, why we use Qs which are 2? Because of we want to store the child and also the parent different. Because as Q goes, it just pushing the child back in Qs. But we want the child to be separate because they are at a different level. So I hope that you guys liked it. If yes, then hit the like button and see you next one. Until then, goodbye. Take care.